Hello and welcome back. Today I have something cool, something I wanted to have for a very long time, and I finally found one, and also it was affordable, and that was of course. Finding some equipment is not always very difficult, but finding it affordable, and I did this time. And well, you have seen me sort of calibrating or adjusting the multimeters that I restore, and then I use this is one of my favorite LBO2, um, or this one was a little bit less my favorite, but it still does the job, and it is a bit cheaper than the other one. And if you really want to have something good, you have here the DMM Jack Plus. And this one is calibrated against a 7.5 millimeter, so you can adjust very well. But it's only a 5 volt, so that means you can only adjust one or two ranges maybe. But if you want to have something proper, then you look for a real calibrator, and I found one. Some of my viewers already have spotted it in the video that where I show my winch system, how to get my heavy equipment upstairs. And there it was in the end of the video, and I already had very slight little, you already could have seen it, but it is here, and it is the Fluke Calibrator, the 5105B. And it also has the option for a GPIB and also the option for wideband. So that means it's not only doing AC up to 10 kilohertz, I think it goes even up to 10 megahertz. So I'm not sure where I'm going to use it, but it was in there and it was tested already and calibrated by the seller itself. So that gave me a good, good sense that it definitely would work. It is from France. I found it in eBay, and let's have a closer look. I will get it on top of my desk. Well, I've got it on my desk, but it is not very interesting to watch because it is so deep, and there is not much to see. So I will try to get another angle of it, but it is like 35 kilo with full options. Well, I don't have full option, but it is at least 32 kilos if I must guess. And it is almost 60 centimeters deep. So it is huge, and it is a few units high. So it's 22 centimeters high. And I only have one spot in my rack that I home built where it fits exactly, so that I was lucky with that. Otherwise it would stick out a lot to the front, but I have possibility to put it properly, as you have seen. Well, let's have a look at the front. Okay, this is it. Big, the 5101B, and I will just put it back in its spot because now I cannot even properly zoom into the device, but this gives me the opportunity now to open it and have a look inside, but I will edit it later in the end, but I will open it now. I bought it in May of 22, and as I said, I bought it in France, and here I have a little note that says Vérifier le, well, it's the March 18, so when I bought it, it was 2 months before that it was verified that it was working. I will take the sticker off because probably I have no warranty on it at all anyway. But let's open it. Well, let's have a look inside. I will put my light. I had some complaints about my light because if I have it at a certain angle it starts to flicker, but I don't think it is doing that now. So, oh wow. I thought you would see a lot of PCBs, but it actually has a whole cover. Okay, well, I try to zoom in a little bit. I hope that is visible. You can see danger high voltage, 1100 volts AC and DC. So instead of just doing 5 volts or 10 volts, it can really go from a few millivolts or maybe even microvolts up to 1100 volts, and it can do currents also, and it can do resistance also. And well, here you can calibrate it again, yourself, maybe against a better calibrator, or if you have a very good calibrated multimeter, maybe you can calibrate it with this also. This seems like DC volt. This is ohms. Here we have AC stuff, and this is for current, HF, so we'll also have here our generator. And what else we have? Interface cards. Yeah, of course, if we need GPIB, it should be there. Well, let's just get the cover off. I want to see what is underneath, and you probably also, because it is kind of boring just looking at this silver cover. It's aluminium, by the way, but yeah, it's a cover. And well, we need to go in deeper, of course. Hopefully I don't miss any screws. This one is still loose, so maybe that is happened with the transport, or they just forgot to put that. We need to kind of remember where all the screws were. I will get my anti-statics, by the way, because I really don't want to damage the device. Okay, let's see if we can open it. Oh, yes we can. What are these little thingies? Wow. I think these plastics are just to make sure that the boards don't shake. I will just, or maybe that we can see which options are in. Well, my first look was at the power supply here, and if I watch, it is to set to up, low, low, and the up, low, low is 220 volts, and I have here 230, almost 240 even, because a lot of people here have solar panels, so the voltage came slowly up here, and that means that the whole regulation circuit of the, here you see some of the heat sinks. So this needs to dissipate more power or voltage, at least, that than it should. So I can make it a little bit cooler, I think, by just setting it to at least 230 and maybe even to 240. But I need to see if it affects the calibration. If it is a proper regulation circuit, it should not. We have a lot of boards here, and we can adjust a lot of things, as we saw on the cover. And but I first like to see, here is a big transformer that's probably the high voltage. I am not gonna do too much. I also leave the PCBs in. I'm sorry about that. I first want to see if it even works, and I'm still a bit careful because it is just in. I will just have a very quick look if the voltage is the same, if I put it to 220, 230 or 240, just to, yeah, I don't want the power supply to work too hard because I know the voltage is really high in this area. So I hope I did not make a mistake by switching it over from 220 to 240 volts, but I do think it is better for the power supply. Because as I said, we have close to 240 here, so yeah, I have here the Echelon 34401A, 6.5 digits. So then we have a good idea of what this calibrator can do. It is designed by Fluke to do 4.5 millimeters, but when you compare it to with the 6.5 or with the 7.5, you can do your own error calculation and use it maybe for more digits. So let's switch it on. Okay, here we go. Well, this should be preheating for 2 hours, I think, and this one also preferably at least half an hour. I just switch it both on. So if it is a little bit off, then that would be okay. Yeah, let's hear. Oh. Okay, that's a good thing that it is this big, that the ventilator in the back is far away. I have only very shortly read the manual. DC volts. I'm now not using any sense wires, but just let's see how it works. We have here the control area. In the lower voltages you have your 50 ohms load, and here it's like open for higher voltages. You have internal or external sense wires. I think this only works on very low voltages that the sense wiring works. And of course standby in operation, so actually put output on it or not. I put it to 0, well you immediately see, and that is because of the 50 ohms. It goes very low because we are here in the microvolt, so it does do its zeroing. And that could be even the meter itself also, because does it even go to 0? Yes, it does. Okay. And for the higher frequency, if you have that option, then you can go here up to 10 megahertz, but then of course you need your coaxial. We have data entry. Here you can set some limits. I do not exactly know what to do. There is a boost module, I don't have that. And external oscillator. Okay, that could be interesting if I could connect it somehow to my external reference. And the data entry. Let's see, 1 millivolt. Enter. It goes here, bloop, the entry, and then it says not AC, so that probably means it's DC, and then we have 1.000 millivolt. Is that true? I would say that is almost true. Perfect. It's a fractional of, but and what if we do 100 millivolts? I did 1 volt apparently. Okay. So it is a little bit high, but it hasn't been switched on very long. And well, for a 3.5 multimeter you would be happy with this, because this is then your last digit. That is usually the plus minus. And the cool thing is it can go very high. So if we go to 100, and I do just volts immediately, we should have 100 volts. So don't touch it. Yes, that is 100 volts, I would say. Stop. Can we do 1000? Yeah, we should be. Volts. And operate. Clack, clack. Well, that is 1000 volts. Cool. Okay, then how? Let me just put it back to 10 volts first. If we want to do AC, I don't see AC or a DC button. But what if we first do 10 volts? And then we have 10 volts. And now I say 50 hertz. Enter. Then it becomes, your DC becomes AC because of the hertz. Okay. And then of course here we need to go to AC. And the AC is a bit low. I hope this is not because of what I did with the power. That would be a pity. Then I need to recalibrate this. 100 volts. Yeah, okay, it's fractional low, so maybe it is now too low. I should have set it to 230 instead of 240. So going from very low to very high voltages is possible, and AC and DC is there. Well, AC I need to have a look at why it is not good, because it has been checked. Could be something I did with switching it over. There is also, you can do current, and we can also do ohms. Okay, so let's put it to 2 wire ohms. Let's do 10 ohms. 0.209. Let's do 100 or 1000, why not, ohms. Look at that. And this is with 2 wire, and that's why the lower values probably didn't work that well. What if I say 10 kilo ohms? I did 100, apparently I double tick. Okay, and it should be able to go very high. If I say 10 max, is that possible? Meg, or is that milli? Deze, 10 meg. 10 meg ohms. Yeah. Yes, it does. Wow. What if I want to do current clear all? Okay. And let's do DC current. This one. Let's put 1 milliamp. It operates very easy. Oh yeah, that is 1 milliamp. Look at that. And you see it's now dropping a little bit because it starts to get into temperature, and then it is getting even better. And can I do a whole amp? Yeah, let's just try it. 1 amp. That would be cool. That you cannot do with these little loop calibrators. Oh yeah, you can do a full amp. Cool. Okay, let's try that also for AC amps. 150 Hertz. Operate. Yes, that is 100 milliamps. Can we here also go to 1 amp? That would be interesting. It's still 50 Hertz. Okay. Yes, look at that. That is AC. Here the AC is also a little bit low. And it can also do frequency. So 1 volt, 50 Hertz. 1 volt, frequency 50 Hertz. Now I'm not sure if this meter is low or that this one is a little bit low, but it is something then that we need to adjust. Let's go to 400 Hertz. Oh, it is already picking up from its cable, I think. Yeah, it's just low. Now it's 400 and it says 390. So I probably need to adjust the AC frequency. Yeah, now the fun part, which meter is correct. I set that on the 1 volt setting on AC, it was a little bit low. Well, the Agilent thinks it's a little bit low discreetly, but this one is second hand, homemade adjusted. Says it is a fractional high. This one is a pico test. It is also like a Keatley 2100. It even says it is a little bit high, but almost there. This one is low, this one is low, that one is low, and the Bryman, which I trust a lot, also says it is a fractional high. So yeah, which one is correct? Well, you will always see that on AC that there is the biggest error, or it's less precise on AC. You will see that in all multimeters. And it also depends. Some are calibrated with 400 Hz and I'm just now testing with 50 Hz. But I did test on 400 and it was also not good. But if I'm back to DC and I put 1 volt, then we have a lot more agreement, because it is 1001, 10001, 10001, 1001, and so on DC I'm very convinced that it is okay at least. Yeah, I need to see what I will do with the AC. Yeah, this is always the biggest problem if you buy a calibrator second hand. Is it properly calibrated? And this was a second hand and it has been refurbished by the owner itself, and then it is also well, was his meter good or is my meter good? And also it is built for 4.5 digits and I'm looking at it 6.5. So of course we will see a little discrepancies with that. But I like it, it's super flexible. Instead of just doing 5 volts or from up to 10 volts, I can really now go from a few millivolts, I think 10 millivolts, up to 1100 volts. I can do that in AC and in DC. I can do my ohms starting from, I think 10 ohms all the way up to 10 mega ohms. And the amps, I don't know by my head, but I think we already tested one, but maybe it can do even 10 amps. So that is quite cool. You don't do that with your cheaper Fluke calibrators. And the voltage range is now so big, I think I should not have a problem just following any calibration manual now. And as long as I just keep my echelon there, just to keep an eye if the calibrator is behaving as it should, I think this is great to have. So that was it, a quick look on my calibrator, the 5101B from Fluke. And yeah, I like it. In DC it's almost spot on. AC I will need to have a look, at, and also the frequency, because it's a little bit low. Instead of 50 ohms it was already 48. So, and of course if you then go in higher frequency the difference will be a lot bigger, but that is no problem for me. I have my GPSDO, so that will be fine. That's the least of my problem. I do need to look at the AC, but the DC is already spot on and the ohms also don't look bad at all. So I will give it a clean, and also, yeah, the next time I'm going to calibrate it, I need to read the documentation first, what is needed for that, and I probably need to heat it up for a long time, so I really need to prepare for that. So, well, I hope you enjoyed it. I did. Thank you for watching, and hope to see you next time.